Uh, in the previous class, we have talked about different type of forces, and we have reached at contact forces. Let see again about this force. Mm, Contact force. When one body remains in contact with the other, the force related or operating between the surfaces of contact is called contact force. It is of two types. First one is normal reaction. It is of pushing behavior. It acts between surfaces in contact and normal to the surface. For example, here situation is shown. A body is placed on the any surface or table. Then the table will exert a normal force. Table surface will exert a normal force on this body in upward direction, and this body will exert a normal force on table at contact point in the uh, normally in the downward direction. It is shown here, that is this body experiences a normal reaction in the upward direction, and this normal, it is also called normal contact force, and this is experiencing, the table is experiencing a normal force in the downward direction. Now if you write the FBD, that is free body diagram of this body, then here two forces is acting, one in upward direction and another is downward direction. Here it is shown the normal force is acting in vertically upward direction, and the weight of the body is acting in downward direction, which is mg. Now in this situation, here these bodies are also in contact, and this body has mass small m, this body has mass capital M, or m1 and m2, whichever you find convenience to represent, and it is placed on the body and they are in contact. Then different contact will arise between them. For example, the different contact force here is shown, that for example the table and contact force between table and body is R1 for this body, and R2 for this body. It normal reaction on normal contact force it is called, and in this body normal force, normal contact force in this direction and in this direction, which is represented by n. Here we are only contact force is showing. Now when we draw the FBD, free body diagram of the body, let first we are drawing the free body diagram of this body, which have mass m. Then this body exerts a normal force on this body in this direction, which is shown as a n, and table is exerting a normal force in upward direction, which is shown with r1, and the weight of the body is working in vertically downward direction. So this is the free body diagram of this body, and similarly we can draw the free body diagram of second body, which is shown here. Another situation is shown. Two bodies are placed in contact on an inclined plane, and here also different contact forces are acting. For example, here table, this inclined plane is exerting normal reaction or normal contact force in along this direction, because contact force always acts perpendicular to the surface. So normal contact force, not contact force, or normal reaction, normal contact force or normal reaction. But if you ask only contact force, then it will be the vector sum of normal reaction and friction force when friction is countable. Now in this body, here only we are considering only normal reaction or normal contact force, not showing friction force. Now further we will show also friction force. So in this now normal contact force between these two bodies and inclined plane and this body is R1 and R2, which is shown here in this diagram. Now we draw the free body diagram of this body. Then if you draw this free body diagram of this body, then one force will be in this direction, and but weight will be in this direction, like in this direction, and one normal force will be in this direction. Now here FBT of that body is drawn. Here the situation is shown. If this body is of mass m1 here, and we are considering the body mass of this body is m2, then if we draw the FBT, that is free body diagram, then normal reaction due to inclined plane is in this direction, perpendicular to the plane surface, and normal reaction due to this body is in this direction, so it is shown here in this direction, which is we have written n1, and weight will be acting vertically, directly vertically in downward direction, so here m1g represent the weight. So three forces are here acting on the body. Similarly, we can draw for second body normal reaction R2 in vertically in this direction, N will be in this direction, and M2G will be in this direction. Now there are different types of contact and normal reaction. We will see one by one and discuss the different situation. For example, here point contact or pivot contact is shown in this. For consider a rod is put like this, then on this point normal reaction will be in this direction, on this point the normal reaction will be in this direction, and weight of the rod will act in vertically downward direction. But same rod is put like this, put like this, placed like this, not put, placed like this, then the normal reaction will be acting in this direction. This is the difference between this situation and this situation. Here normal reaction will be acting in this direction, but here on the ground this normal reaction will be acting in this direction, and the weight of the body is vertically in downward direction. That is, weight of body will be passing through the center of mass, maybe some situation. Here another situation is shown. One rod is placed on the knife edge, and then such type of situation is created. This at this point the normal reaction is in this direction, or normal contact force. Here R1 and R2 is shown. For this is R2 and for this is R1, and the weight of body is vertically in the, acting vertically in downward direction. Now a rod is placed in the ball, then this situation will be arise. Normal force will be acting in this direction. Here the normal force is in vertically upward direction, weight is acting in the downward direction. Another situation here also is shown. A rod is hanged with the string, then normally here tension is acting on this direction, normal force in this direction, and mg in this direction. So we can draw see different types of situation and draw different free body diagram for different situation. Now the second is surface contact. In case of particle, the normal reaction always passes through the center of mass. Particle or body. In the case of rigid body, the normal reaction may not pass through center of mass. Okay, so sorry. In case of particle, the normal reaction always passes through the center of mass. And in case of rigid body, the normal reaction may or may not be passed through the center of mass. Now the third one is ring contact. In this case, two-dimensional reaction force is acting at the point of ring. For example, here we see it is this situation is called hing, and here two normal forces acting, one in this direction and another in this direction. Here also same situation is here in one in this direction and another in this direction. Weight is in this direction and normal reaction is in this direction. Now the second case, friction force. It is also a reaction force, contact force. It is also a contact force which always acts along the surface in contact. This force can exist only when there is a applied force acting on the body or the system. B. There is a relative motion between the surface in contact. C. There is the tendency of motion. The friction force will oppose either one of the above condition. If three condition is fulfilled, then friction force will arise. Now types of friction force. First one is a static friction force. It will oppose the tendency of relative motion between the surfaces in contact. Uh, Here the situation is shown that it arises when there is a tendency of force, that is tendency of movement or relative motion between the surface, then this force is arise, but body is not moving. Uh, May be moving, but here it will depend on the situation. For example, here we see here two bodies is shown. One body is placed on the table and connected with a pulley and a string. There is another body of mass m. Now, because due to the weight of this body, this body have tendency to move in this direction. So there is a relative motion between surface of body and the table. So force of friction will arise, and force of friction is always acts opposite to the relative motion of the body or motion of the body, because this body is body this body is moving in this direction, have tendency to move in this direction. So force of friction on this body will act in this direction as shown in now the free body of diagram. If we draw the free body of diagram, FBD of this body, this will be like this. Here the tension is acting in this direction. Normal reaction, that is normal contact force of table or surface, is acting on this direction, particularly upward. Weight of body is acting in the downward direction. Force of friction is acting in this direction. Uh, and for this body, if you draw FBD, then only two forces is here. One is tension of a string, and the other is weight, which is shown here. It also acts when body is not moving. It acts when body is not moving. So here the situation is shown again. A body is placed on the uh, inclined plane. Now the body have tendency to move in this direction because mg will have one component in this direction. If this is theta, then component of mg will be mg cos theta in this direction and mg sin theta in this direction. And due to mg sin theta, it have tendency to move on this direction. So a friction force will arise in this direction, and if body is in rest, then this force and this force will be equal. And because body is at rest with respect to this surface, so at that time the friction force arise in the body is called a static friction. In this case, it is a static friction, and normal reaction acting on the vertically upward direction. One point is to be noted that it is self-adjusting but limiting, and it may provide motion to the body, and this force also provide the motion. Maybe there may be situation where this force provide the motion to the body. And from example we can see here the situation is shown. Three body 1 2 and 3 are placed on a table as shown in the figure, and it is connected with a string and pulley system, and then another body here is shown. Now the body is in motion. So if we draw the, if all body is moving, what will be the situation here we have to see. For example, if we draw the free body diagram of this body, then this will be like this. T will be in vertically upward direction, and weight in the downward direction. Here we are considering the string is massless, and there is no friction between pulley and string. Now if we draw the free body diagram of body 3, then this body have tendency to move in this direction, and tension in the string will be T, because string is massless. So in everywhere the tension will be same. So this is T in this direction. Now this surface will apply a normal force in vertically upward direction, which is shown as N3, and weight of the body will be in vertically downward direction, which is M3G. And again this body, because this surface is also contact with second body, so second body also apply a normal force vertically perpendicular to the plane. So this body will apply a force on this direction, which is represented by N2. And now there will be a friction force. If body is moving, then there will be a frictional force between this surface, because body is moving in this direction, so friction force on this surface will be in this direction, because here the body is moving, so there is no static friction here kinetic. The friction force will be called kinetic friction and represented by Fk. So it is kinetic friction. And also here another tension will act on the body, because it is also connected with a string, with another string. So here tension is T dash. Again if this body is moving, so here also a frictional force will arise. Because this body moving in this direction with respect to this body. So in this surface the friction force will work in this direction. So this is the situation. There may be different situation. Again the second body free diagram is drawn. Here we see the normal reaction is acting N2, and weight of body is M2G. Body 1 also apply a normal force, which is N1, and because and now because this body one body is on rest on the two, so in this surface force of friction which arises will be static friction, which is shown here, because this body have tendency to move in this direction with respect to this body, so force of friction is in this direction. And here the tension in a string is shown by T dash, which is T dash. So then we can draw constantly different situation. We can draw the FBD taking different situation. Now for one body we see, because this body is moving in this direction, one is at rest on the second body. Now because normal reaction will be in upward direction, which is written as 1 1, and force of friction, because this body have tendency to move in this direction with respect to this surface, so force of friction will be in this direction, which is written as Fs. And because body is rest, so it is a static friction, and mass of the body is just weight, which is in downward direction. Now another situation is shown. A body is placed on a car, and which is moving with acceleration a, and this body is on placed on that car. And what will be the situation? Because now, and body, when we are seeing from the earth, this body is in rest with respect to this car and moving with respect to us. That is, body is not sleeping on this surface but moving with respect to earth or earth surface. Then situation is like this, because if we see here, this body, this surface is moving in this direction, have tendency. So respect to this, respect to surface of this body, this surface is moving in this direction, so force on this surface will be in this direction. But this body has, with respect to this surface, the body of this surface is moving in, have tendency to move in this direction, so force of static friction will act on this direction on this body where it is shown Fs. And non-normal reaction will be in vertically upward direction, and weight of body will be acting in the downward direction, mg. So this is the free body diagram. Here we see that due to here even there is a static friction, but body is moving. So it depends on the situation, which situation we are going to take. Here only difference is that we are seeing with respect to earth, and body is moving with respect to earth, but body is in rest with respect to car surface. Now a static friction force can never reverse the tendency of motion. That is, for example, here see a body is placed on this inclined surface, then body have tendency to move in this direction, because one component of weight will be in this direction, and that component exerts a force on this body, so this have tendency to in this direction, so force of friction always will be in opposite direction, and this cannot reverse. The magnitude of the static friction force is given by Fs less than equal to limiting friction, or Fs maximum in general, and Fl equals to ms into 1 in limiting condition. So Fl equals to limiting friction equals to Fs into maximum limiting friction force, and n equal to normal reaction, and mu is the coefficient of static friction. So this is the condition, because static friction is always less than and smaller than limiting friction, that is maximum static friction. We know that because friction force is self adjustable, and we have earlier discussed about the friction force. So this is the condition for this situation, and it is shown by the graph. For example, we are applying of course F applied is on this axis, and frictional force arises in the body and or surface, between the surface of the body is in this on this axis. So we get, as we increase the force, the force of friction also increases, and a time reaches when the force of friction becomes maximum, and after if we apply increase the force, the body will start to move, and the force of friction decreases a little bit, and that decreased force of friction is kinetic friction. That is when body gets motion, or surfaces are in motion, then kinetic friction start to act, and so the maximum static friction is called limiting friction. This is here shown.